Hi guys, this is the second video for today. We're on proving identities and page 425, 23 through 28. So we look at the given, we need to prove, which means we take the first side and we try to show the second side. So I took the first side, I see a sign of a difference. I look in my identities, sign of a difference is identity 29, which equals sign of the first cosine of the second minus sine of the second cosine of the first. And we mean first angle, second angle. First angle is x, second angle is pi over 2. We apply the identity. The cool thing is about pi over 2 is that it's a remarkable angle. So when you say cosine of pi over 2, it's a 0. It cancels out all this first term. Minus sine of pi over 2 is 1. Cosine x, we just copy it down. Again, we did not take that side. We just took the first side, elaborated, and then we're just substituting whatever we can, and we got negative cosine x, and this is exactly what we needed to get. That's the proving. Take one side, try to get the second side. I did ask you to skip 24 because it has to do with 10, and that's our work for tomorrow. Number 25, it's a cosine of a difference. And as you guys see, cosine of a difference, that would be 27. It's cos, sine, sine. If it's a difference, it turns into a sum. So you do the sum, cos, cosine first, cosine second, sine, sine. Sine first, sine second. Cosine of pi over 2 is 0. 0 multiplied by anything cancels out all this term. It's not, by the way, cosine of 0 here. It's cosine x multiplied by 0. And 0 is the substitution of cosine of pi over 2. Sine x and sine of pi over 2 is 1. This cancels out. We're left with sine x. This is actually what we needed. This is number 26. Pretty simple. I'm sorry, it was 25. Now we're on 26. I highlighted it. And then you can see this one is a little bit more challenging. And the extra challenge is, I don't know if you can see it really well because it's highlighted. It's going to be a little challenging to see it. But you guys have it in front of you on the blog or in the book. It's pi over 2 minus x, parentheses, minus y. So it's very important to label which one is your first angle, which one is your second angle. The first angle is pi over 2 minus x, all of it. The second angle is y. So it's a cosine of a difference. That's why it's identity 27. So it's cos plus sine sine. So it's cos plus sine sine. So cosine of the first, and the first is this whole mess. As you see it right here, I labeled it as first, multiplied by cosine of second, and the second is the y, plus sine of the first, multiplied by sine of the second. When you write this, you guys should remember previous identities that we have learned in this chapter, which are the cofunction identity. Cosine of pi over 2 minus x is the sine of x. You can check in your identity sheet number 15. Multiply by cosine, and sine of pi over 2 minus x is cosine x. You can check identity 16. Multiply it by, just copy down the sine. So now, if you look at this one, it's very similar to number 28, that side of it. So it's a sine of a sum. So it's sine of the first plus second. Okay. Number 27. Pretty simple. Just applying the sine of a sum, which is identity 28. And as you guys see, cosine of pi over 6 is square root of 3 over 2. Sine of pi over 6 is half. We try to put the coefficient before the function, and that's how it turns into a square root of 3 over 2 sine x plus half cosine. That's what we needed to prove. The last one, similarly, when we get square root of 2 over 2 multiplied by cosine plus square root of 2 over 2 multiplied by sine, that last step is important. How did it turn that way? We actually factored out square root of 2 over 2. Imagine you had 2 cosine plus 2 sine. you can basically take 2 into as a common factor and parentheses cosine plus sine. Here, you don't have 2, but you have square root of 2 over 2. This is the common factor that you factor by. And I hope this helps.